Okay, so let's continue our series of calculus for beginners. This will be the third video of it, and from the last two videos, we have already seen a couple examples of how we should find the expressions with limits and some brief idea of what limit is. So this time we're going to look for the following problem. So again, this is just a video for people who want to have, especially for beginners, to have a better understanding in some concepts in calculus, or to help them learn better for their class. So something that's very fundamental or foundation from the class will not be talked about or explained that thoroughly, and I'll just give some examples that how we are going to apply those ideas. So here is our example. Suppose we have a function of y, or we can just give a different name. Let's call it h of x, which is actually a product of some other functions, f1 of x times f2 of x dot 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 up to fn of x. So we're kind of making it general, of could be 3, could be 4, could be some finite numbers of functions multiplying together. And also we could have some of the functions being the same. Let's say we can have f of 1, f1 of x is just equal to x squared, and then perhaps f3 of x is also x squared. Okay, it didn't limit that each one is different, but of course, even if they're different, it will still be okay. So the idea is, now we have a new function y. How should we find the first derivative, y prime, also known as dy over dx? So before we get into the solution, we need to keep in mind that we have a tool that we need to use also from a calculus course, which is the product rule. And the product rule says that if we have a function, again, any name, just another y, which is actually a product of two functions, f of x times g of x. And again, f and g could be the same, could be different, depends how you want. But in here, we just make it general, so it doesn't really matter. Then we're saying that the first derivative, or the derivative with respect to x here, d over dx, is actually equal to the derivative of the first function, or known as f prime of x, times the second function itself, g of x, plus the first function, f of x, times the first derivative of the second function, g of x. Again, we just need to keep this in mind right now. We're not, I'm not going to explain how we get this here. I'll try to find another time and make a video to talk about why this is true. But anyway, now we have the product rule. We can kind of see how we can get this. So we're going to do the following. Since we're saying that h of x is a function that is actually a product of many functions. So what can we do? Well, now we can do this. We're going to, of course, look at this big function here, and we're going to separate the function by the following way. So how should we do this? Well, since we want to use the product rule to help us, then of course, we need to split the product of n terms into one term times something else, so that we just have product of two different functions. And again, since we're saying that this function is just a product of n different functions, meaning that we can just multiply any of the two small functions inside, and then it will give us a function still. So in this case, we can just group like this, so that now we throw the product rule back in to give us the first function with the first derivative. And here I'm going to save my time and not going to write of x, since we know that these are functions that's depend on x. Then we're going to multiply with the second function here, which is here. Everything inside of the brown parentheses. So we will have something like this. And then plus the first function times the derivative of the second function, which in our case will be everything inside of the gray parentheses. And let me graph like this, or write like this. Good. So now we kind of figure out what the first term is, because again, these are everything that we know and we cannot really do. So for the first part, we just have f1 prime times everything else is just themselves without any prime, like this. f2, f3, all the way up to f of n, well, fn. Then what should we do here? Well, now we're going to use the product rule one more time to figure out what we need to do to this product, right? Then we'll actually get, again, we will take the first term, separate out from the rest to give us the following, like this. And then we will end up with something like this. Good. And then if we throw it into the product rule, we will get the g prime of x again, which means we have to find the derivative of f3 times all the way to fn. Then we in fact can just continue the game until we actually hit the last term fn and then take the prime, and then seeing that everything else will just become we just keep it as it is. Then this is our answer. So how does that help? Well, suppose we now have a function such as let's say if we have something like y equals the product 2x minus 1 times 3x squared plus 4x, and then we're going to multiply with let's say 3/4 times x minus 1/2. Then of course, one way of doing it is we can just multiply all the terms to get a polynomial out before we take the derivative. But as we know how to manipulate with the product rule and then play around using this idea here, we can also just use this general version of product rule to help us find the first derivative without multiplying all the terms in. Okay, perhaps it seems like it's easier to do it since there are only 3 terms multiplying. But let's say if we get more, we will find out that it is actually a lot easier as if we try to use the general product rule to help us finding the first derivative instead of multiplying in first before we take it. Okay, so that's it for today's video. Hope you enjoy it. If you have any thoughts or any ideas or stuff that want me to talk about, you can leave your comment below. I'll see you guys next time.